The reason why others are getting promoted and you are left behind is not your performance. Because while I've been grinding as the hardest working middle engineer in a team, other guys who seem to be doing much less were getting promoted instead of me. So in this video, I will give you a 5-step system for positioning yourself for a senior backend engineer role by changing what you focus on, working less hours than you are now. Step 1 is literally the reason why I was stuck at average middle level for years, and it's this. Engineers are paid according to the complexity of problems they are able to solve, not according to how hard they work. And here is why. Let's say a company has one engineer who works 10 hours a day on simple tasks, same technologies, and does it quickly. And another engineer that is not as productive, a bit lazy, but every once in a while solves a very complex problem that others can't. Who is easier to find a replacement for? The first one, right? The harder it is to replace you, the more companies would pay to keep you. So here is how you can become that lazy, clever engineer. I was working at a company that never required senior level expertise. That is a dangerous situation. That's why you see middle engineers with 15 years of experience. So after wasting enough time like that, I started allocating 60% of my effort to coding my own projects that expanded my understanding and reading books, and only 40% on the tasks my job required. While maybe I wasn't the best performing engineer on a team, complex projects did eventually come, and I was the one trusted to handle them. That shifted my reputation from a hardworking guy to a clever one, and that did wonders for my performance reviews. And some of those problems are problems where architectural decisions will determine the next few years of development. Problems where performance or stability becomes a business threat, and problems where no one else wants to take responsibility. When you learn how to handle these, you're investing in yourself as an asset, so companies, including your current one, will fight to have you. But here are some specific key problems you want to focus on. Any kind of performance or security-oriented problem, because they force you to have deep understanding of technologies and computer science in general. So next week you can do this. Profile a slow endpoint and suggest one measurable fix. Run a basic threat modeling pass on a service and present gaps in security. Second one is new projects. Setting everything up from scratch develops one of the most important traits of an independent engineer. You're responsible for the future of that product because the patterns and structure you set up determine its success. So you can do this. Volunteer to own the backbone of the next project. Create and present architecture doc with all important design decisions. Expect to be critiqued by more experienced devs, but don't drop it and revision it until it's good. The third one is refactors. If you make the whole team more productive by improving the code they work on, you set yourself up for the next promotion immediately. And this is the easiest one to implement next sprint. Identify one messy module that everyone avoids to touch and do this step by step. Use AI to write regression tests for all components or the whole module if it's untestable. Decompose existing code into initial requirements for the module. Come up with the best design you can with the help of AI consultant. And implement it continuously running regression tests. This is how you win the team's and managers' respect and get promoted. Now let's move to the step 2. Look, I interview people from time to time, and if you come to my interview and I see this mindset in you, I'm giving you my strong hire rate immediately. I'm talking about your knowledge of how tools work internally. I've got my imposter syndrome when 4 years ago I was humiliated in an interview for a big company and I wasn't able to answer any question about how Python works. Man, that was absolutely horrible, but now I can't stop diving deep into everything, and that's why I know how stuff works. That is actually the reason I'm able to solve hard problems, because I know what exactly is going on inside. If you don't understand how your tools and frameworks work, you will hit a ceiling where you can't debug, optimize, or design a good system. As a specific example of what I'm talking about, I think backend engineers should be extremely good with databases. You have to know how they work, man. Every day you work with databases, but you might not even consider how the queries you write are executed. But how are you supposed to know what is a good query and what's not? And that goes for all the tech we are using, from operating systems to cloud providers. Wait, what? How can I understand cloud provider internals? Yeah, we were deploying the service to AWS Lambda, and I, a certified solutions architect in AWS, by the way, didn't know how Lambda cold start works. And the thing is that before Lambda starts running, it sets up an environment in a VM that is shared across all future Lambda invocations, and that allows to save latency by moving setup tasks to the global scope of your program you deploy to Lambda. And that is a massive thing you have to know, but you can deploy to Lambda for years not knowing this if you never ask how does it work. So here is my framework for learning internals of existing technologies that will allow you to be an expert in the tools you use every day. It consists of 3 steps: ask, note, and interview. So first, create a node bank in a Notion or whatever software you use. This is essential. First step, ask. Every time you use a technology and feel that you have a gap in understanding of how it works, ask AI to explain the internals and don't give up until you easily understand it. Read source code if needed. For example, if I'm coding in Python and I write this line, and if I come from a statically typed language, I don't understand how values of different types can be in one array, right? Then I ask AI about it, and it turns out that internally it is an array of values with the same type. But the type is PyObject, which is a reference to a real data in a memory, which is very important information for all Python programmers. Second step is note. After understanding how it works, document what you've learned in a node bank in a clear and short sentence, 1 sentence. And this is my node bank for PostgreSQL internals, and I update it from time to time, for example. And the most important step is interview. You have to interview yourself in your brain from time to time with the questions you've already learned in the past. Be honest. Ask hard questions that you feel you might already forgot. The research says that to effectively learn a piece of complicated information, you have to have like 5 to 7 successful repetitions. Then never stop using this framework and make it a habit. Get this mindset and you will feel much more confident to make good design decisions, have an easier time resolving incidents, and pass most senior level interviews. I don't know about you, but I don't believe AI will replace engineers. But I do believe it will expose engineers with poor judgment. And this is step 3. Here's what I talk about. Your judgment is a foundation on top of which you build software. Nowadays, AI allows to stack code super fast. So if your foundation is weak and you just continue to stack new features on top of it, it will crash extremely soon. Almost every day I review PRs from middle and junior engineers, and these 3 bad patterns I see over and over. Code that works but can be tested, patterns that break with the next feature, and abstractions that slow everyone down. Judgment is your ability to set up patterns that will streamline the process of developing features in the future for your coworkers and AI. So here is a simple 3-question judgment framework I use when evaluating any solution. Before writing code, validate it against these 3 rules. And first one is friction. Will this reduce or increase friction for someone who didn't write it? Second, isolation. Can this code be tested, swapped, or removed independently? And conventions. Does this fit into existing patterns of the codebase? When you apply this framework, your decisions are getting much better. You choose architectures that allow implementations to be replaced independently. You create extension points instead of massive functions, and you follow existing patterns instead of inventing new ones. People who review your code can always tell who is actually thinking about these questions and who doesn't. If you apply this framework consistently PR by PR, your work will stand out instantly and people will notice the difference in your judgment. Cool, let's move on. Unfortunately, if you miss the step 4, none of previous steps will work. Because as important as all of them are, management is not going to see your effort if it doesn't impact a specific business outcome. Investing time into designing a scalable system that doesn't really need to scale is not going to promote you, but it can definitely fire you. What I notice about us engineers is that we are so obsessed with technical things that we almost never actually think what is more important for the company. I hear this ownership word everywhere, and it actually has a meaning of owning a piece of business. Ownership means optimizing for business impact, not technical elegance. So here's a list of things that engineers think will make them a senior, but it doesn't. First one is clean abstractions that complicate the dev process for entire team. Second is scalability just in case with expensive builds. And switching to mainstream tech and architectural patterns without a clear business outcome. And here are things that are actually promoting you to a senior. Reducing risk that actually comes from good design. Saving money or time that comes from optimizing scaling techniques. Enabling revenue for the business that comes from writing clean code because it allows you and your team to focus on important features instead of fixing endless bugs and spaghetti code. And preventing incidents that leadership actually cares about. And it's possible by maintaining comprehensive test suite and predictable logic. Okay, so before writing anything advanced, write a short design document. If your company already has a design or RFC process, use it and take ownership of slightly bigger problem that your role requires. And if it doesn't, introduce a lightweight version yourself. It shouldn't be big, like 1 or 2 pages is enough. And answer these 3 questions there. What business problem does it solve? Cost, risk, like revenue or customer pain. What happens if we don't do this? Rough numbers are fine here. And what's the smallest acceptable solution? Not the cleanest or coolest one, not the most scalable one, the one that solves this problem. This works because design docs make your thinking visible, and visible judgment builds trust. 3 things will happen to you after you do it consistently for some time. Management starts trusting your judgment. You get pulled into high leverage work, such as design discussions, risk assessments, architecture reviews, and you work fewer hours with more impact because you stop building things that don't matter. Step 5 is where like 95% of middle engineers fail, and here's how it works. You have to get good at communication. I worked with a very talented engineer for a couple of months, and I think we actually had a pretty similar mindset. He's been great technically and was able to set up a great project by himself. But he had a problem. He couldn't clearly explain his thoughts and ideas, and also management had a pretty hard time communicating with him. So he was let go. I'm sure he's already employed because he's great, but this made me understand how important this soft skill is, potentially even harder than other hard skills. And here is the example of a meeting with a project manager where engineer can say, I discovered a database engine is not using indexes for this query. Instead, what you should say is, we found the query powering this new feature takes 28 seconds. Every time a user does this action, they'd wait 28 seconds for the page to load. Not being able to communicate a technical problem to a non-technical person can be a reason for you to lose your job, even if you are a great programmer. So here are 3 rules of communication you can never break. because believe me, they are super obvious to everyone but the person making them. First, avoid using technical terms when simple language works. For example, instead of saying idempotency, say it's safe to retry without creating duplicates. Second, always give context before starting to dump technical details. For example, start with "this helps us reduce user drop-off" or "this speeds up onboarding." And third, keep it short. Oh my god, it's so frustrating to listen to something for 3 minutes that could be said in 10 seconds. You can't waste anyone's time. Successful backend engineers are extremely good at translating thoughts and ideas into technical details, which lead to asking correct questions. Questions create clarity that is so needed for a streamlined dev process. What I've seen happening is product and engineering team being in a constant process of feedback rounds and iterations because there's a mismatch between technical approaches taken and expectations. And while it's not your job as a software engineer, maybe, being able to ask a correct question in a right point of time can potentially save your company a lot of time and money. Becoming a great communicator combined with mindset we talked about in previous points makes you the best candidate for a promotion to a team lead. So to become a more confident communicator on your job tomorrow, do this. Before every meeting, get prepared, even if you are not the one leading the call. You should think about what vital questions do you need to ask to clarify requirements and make your work more straightforward. Do people on this call need to know about any tech constraints or problems that impact business requirements? And if so, how can you deliver each of these constraints in a clear and simple way that will make their decisions easier? And how can you transmit more information in less words to not waste anyone's time? This gets you into meetings, helps you influence decisions, and spread your impact on a company, which leads to being irreplaceable. So there you have it, a 5-step mindset system to get to a senior level. Solve hard problems, understand internals, exercise judgment, own outcomes, and communicate clearly. It's what makes you trustworthy, promotable, and able to solve kind of problems companies actually pay for. But I wanted to tell this. AI can either multiply that foundation or completely destroy it. Most developers use AI in a way that makes their code worse, their judgment weaker, and their reputation drop. Seniors use AI in a way that makes them look 3 times more effective without even working harder. So in the next video, I'll show you the exact 3 AI workflows that multiply everything you learned here and never damage it. So go watch that video if you want your foundation to turn into real visible impact.